Welcome everyone, thanks so much for coming tonight. Really appreciate it. I just wanted to let you know that this is the only San Francisco Blockchain Week event in the Valley for the whole week. So yay for the Valley. I'm pleased to introduce you to Jae Yang. Jae's been incredible support, particularly last year. We did about 3 Ask Me Anything blockchain events, and he was a fantastic educator in that. So, did you want to say a few words, Erin? So Erin actually organised the venue tonight, and we really appreciate everything she's done.
Oh, perfect, thank you. Hi, my name is Erin Moeller. I support the Office of the CTO in TIBCO Labs. And TIBCO Labs, it's a program that our customers and partners can gain insight into TIBCO's innovation activities in areas such as blockchain, AI, ML, and IoT. I just wanted to let everyone know the end of March, we are having a blockchain and IoT hackathon here, so I hope you guys all look and register and come join us. So welcome.
Thanks again, Erin. And now I'm going to pass it over to Jae, and Jae's going to do the presentation. Thanks.
Okay, so this is a presentation where I need audience participation. So if you have questions, please raise your hand. There's only 18 slides, so I'll go through it relatively quickly. There are some parts where I do go into kind of weeds, dig deep into what the flows are. So, welcome. So everybody's probably asking, okay, what is this about? Bridging the chains. Okay, how can you bridge the chains when there's nothing to bridge right now? So, well, sadly. So I'm from Tacen, and we're creating a non-custodial exchange where the control goes back to the trader. So we don't take custody of your money. We don't need to know who you are. We have very high standard in keeping your private data private because number one, we don't keep your private data. Therefore, there you go. So if you're interested, please talk to me after the venue. And again, I want to thank you for joining me, and I want to thank TIBCO for hosting this event. And thank you very much, Pimo, for organizing this fantastic event. So, blockchains are sort of islands of states or diffs. So if you're talking about UTXO and Bitcoin, there are different diffs from previous payment states, and then Ethereum actually has a state somewhere. So, but the problem is all of those are on their own. They're not sharing data, and it's very difficult to bridge that gap. And there's a good reason for it, right? So blockchains are all internally consistent. And because they're internally consistent, they make no assumptions about other chains following their rule, and that wasn't the reason why all these blockchain projects have been developed in the first place. They want to be internally consistent so that whatever people are doing with it are all followed through. But then problem is now, once you have people starting to use those blockchain applications, sometimes you want to trade. Sometimes you want to use it as a signal for doing other things. So interoperability becomes an issue. Pardon me. Now, so there are some categories of cross-chain operations. So one is a swap. So let's say I want to trade, I want to swap Litecoin for Bitcoin. That's a swap. Second is a layer 2 collateral. So when I talk about layer 2, that means whatever is off-chain from the main blockchain. So think of Plasma, think of Lightning Network, something that doesn't do its operations on the main chain that it has to, at some point, settle. So next thing is the contingent operation. So let's say there are exchanges that need to price something in some other exchanges are pricing it in, say Bitcoin price or some wrapped ether or something like that, then you need to have like an Oracle connection and get the data from some other exchange. So contingent operations, generally require loosely coupled oracles. So what that means is, let's say you do want to just have a system that's entirely composed of pricing in something else. So you can have, say, wrapped Bitcoin or whatever. then in that case, you kind of have to rely on some other external source of data to tell you what the price of Bitcoin is, if you have some operations that require it. And I'll cover that in a little bit when I talk about Rainbow Network. So there are some building blocks, right? I'm gonna be very simple with this, and then we will build on top of it. So there are two more blockchains. There are aggregated network that handles sort of like, rules and normalizes the protocol so that all the messages being shoved in from one blockchain are translated and then sent over to some other network, right? Secondly, you want to have a mechanism to, have a collateral, because if you're talking about working with multiple blockchains, you want the monetary value in one chain to be immobilized while you're handling some other operation, to be handed over to some other blockchain. Or maybe they both need to be immobilized at the same time. So if that's the case, then you need to have some mechanism that's very robust so that there's no way that your money is locked away indefinitely. So that's what's called hostage taking. So finally, you need some sort of clearance mechanism to, okay, once everything is settled and once everything is good to go, now execute the very last order, and then you swap or whatever, right? And there are some very specific specific problems being solved. Say you want to do like a, prediction market or something like that, and that relies on some of the market state or whatever. And if you want to do anything between multiple and distinct blockchains, you may have to have validator inside a sort of aggregator network that confirms sort of these states and all this, things are being handled properly. Of course, like even if you have just your own blockchain, you still need some sort of validator, and miners confirming that the transactions are correct. Those are validators. So when we talk about aggregated network and protocol, you might not even need an aggregated network. So what am I talking about? You basically, if you have an interpreter, think of it like I'm a translator, and you go to a foreign land, and we both need to talk, so you have somebody in the middle. So that's basically what an aggregated network might be. I'm using a term very loosely. So in a technical language in the blockchain space, they might not use an aggregator as a term, but please bear with me, and if you have a better terminology, just yell at me afterwards. So now, depending on how you want to work with multiple chains, you may have to have the aggregator network rebroadcast the events that it hears from some other blockchain. So maybe the idea is you want to listen to blocks being constructed and block rewards being made in one, and then you want to use that to purchase or sell or transfer money on another blockchain or something like that. That's a very convoluted scenario, but in order to do that, you may have to have some sort of message bus where you have messages coming in from different blockchains, and then you have to have some sort of aggregate network that handles and have the same common language within the network. So think Cosmos, that's one example. I'll cover Cosmos in a little bit. I just wanted to give you a heads up. I don't own any of these. I don't own Cosmos. I don't own any of those. I don't own Polkadot. Nothing. So just heads up. So now, when you're talking about collateralization and things are moving and things are not locked away, then you have to deal with asynchrony because block times are different. Their finality rules are different across different chains. So Bitcoin is not known for its finality. Things are statistically reasonable at some point in the future, but it's not final. Is the block that is accepted by a majority of people, it's still, there are some very small chance that it might not be valid in the future. So where I was going with that is, if you have that sort of difference in rules, then you have possibly a different conditions under which things get settled, and therefore you have a race condition. So going back to collateral, so if I want to think of it like this, when you go buy a car or home, you have to you have to sit down with someone else and say, okay, I want to take a loan for this car, or I want to take a loan for this home, and then you sit down with other people, and at some point, you have a very uncomfortable moment where you're sitting down with your lawyer, and you're like, okay, here's my check, and where's my deed? So we're title, right? Like, so there's a very uncomfortable moment where you have to kind of have a collateralized trade. And blockchain in many cases is very similar. So when you have an aggregator network that has a different economic incentive model, you have to take that into consideration. So, and you also have to understand the collateralization probably is one of the ways you can prevent network spam across when you're working with different chains. And paying for complex computation is another. So like say, well, the preventing network spam is important, but if you want to make sure that, like for example, think Ethereum. That's a really simple case, right? You're putting up a gas, which is essentially a collateral. So if you just look at it in the confines of Ethereum, you're putting up a collateral so that when the program runs, it either pays for everything, or it doesn't, or it goes and it does an infinite loop, and you just lose everything, right? So there's a penalty which is paid for by collateral. So that's sort of the paying for complex computation, and so this one is a little bit trickier. So what this means, collateralization is necessary if network has no rollback or continuous integration plan. And I think all that means is if you have some, unforeseen consequence of your network or unforeseen consequence of a rule of a blockchain, because either things are on the fly, things are continuing to be developed, or rules change, or something like that, or something, some coding errors or whatever. Then, because you can't account for all of that, you might need to have a penalty mechanism, and that's what Lightning Network does. It has a collateral and penalty, and it's possible that you, as a node, might lose everything. It hasn't happened yet. It's a very robust network, but it's possible. So you make room for it. Similarly, and finally, collateralization is necessary if you want it to be a network settlement layer, because you need something that is neutral, and that's not you and that's not them, that holds the money in between.
Excuse me.
Yeah.
Quick question.
Yeah, of course.
So can you help me understand the network spam? What do you mean by that?
Network spam.
Yeah.
So let's say that you want someone to be a valid player in the network. Then they might ask you, okay, well, I need you to put in like 10 Bitcoin into the network, so that then you can start sending out transactions or whatever. I don't know if that's the case right now, but that might be a rule in the aggregator network. So that's one way to have a reduced sock puppet, kind of attack. Okay, perfect. So what's hostage taking? So when you say collateral and someone has your money, someone else can also take hostage of your money. So that's what this is. And basically, it's very self-explanatory. Locked away even though operation's been done. And it could be a number of reasons why that's the case. It could be race condition. It could be just someone just not testing all the edge cases when they're writing smart contracts. Or just you thought you were executing a one transaction under one smart contract condition, but then there was something that you didn't take into account. Like for example, there was a path in the smart contract program that you didn't take into account for. So that's a very likely case. And when that happens, it might be inadvertent, it might be intended, but whatever the result might be that your money is totally locked away. And it does happen fairly frequently. There are tools to discover whether that's the case too. Now, if it's just on single chain, so when you collateralize something, you're creating you're sending money to some some neutral at some contract address or something like that has some rules that are dependent on somewhere else. So when you have that, then you have to understand what you're sending money to, and that's very important. Now, And finally, if you have any step that requires manual interaction, which is sort of like what I'll cover in the hash time log contract scenario, it's possible that you might lose money. So I just want to talk a bit about centralization. So centralized exchange, if you really think about it, is just a bridge between multiple chains. It really is, because when you go and you put in Bitcoin or whatever, and you want to trade it for Ether, they're just handling all they're just acting as an intermediary, right? So they have the databases that handle user account, who has what, and so on and so forth. So if you really think about it, that's basically what they are. But now, what that means is they also act as a single point of failure. So if you have a central authority that tells who owns what, it can be hacked, it can be taken over, and God knows, right? So jumping a little bit, yes.
The previous slide,
Mm-hmm.
the whole reason why Bitcoin came into existence is to overcome this centralized
Correct.
authority, right?
Yep,
So
yep.
what's the point of putting this centralization again?
Great question, great answer, great question, and I have an answer for you. So whenever you have something that is an asset and someone wants to buy, you have to have a link back to the physical economy, right? So in Bitcoin's case, it has to be US dollar. So if someone wants to buy Bitcoin and someone wants to sell Bitcoin, you have to have some sort of exchange. Unfortunately, people didn't start with a decentralized exchange. If they did, we would be in a very different world. Because they started with something like Mt. Gox or some, OTC desk, that's essentially the reason why you need some sort of centralization. So the decentralized way might be, I come to you and meet at the coffee shop, and I say, okay, here's $10, can you send me Bitcoin, right? So that's like peer-to-peer, and that's going back to the roots. But because, if you're in New York and I'm in San Francisco, it's a little bit different. So then you need the degree of centralization that's necessary for handling money. Someone needs to have an escrow of your money and then all that stuff. But yeah, absolutely. And that's, I think, what most people don't ask that question frequently enough, and I think everybody should ask that. Why do we have all these intermediaries when we can, build around it? Fantastic question. So oracles are, it's not a giant company over there. It's very poorly chosen, and I should have lowercased it. So because blockchains are these isolated pockets of information that have their own rules and their own informations, what you want is, let's say I want to get a temperature in San Francisco for some sort of like betting market, right? Like a prediction market. Then the consequence of settlement for that prediction market has to rely on some source of information outside of Ethereum, which means that smart contract has to make a call out into the outside world. That seems like an easy problem to solve, but actually there's a lot of problems that can happen just in the same way that if you go to a public Wi-Fi, there might be a lot of problems. So oracles provide external information, and they might be useful for some smart contracts. And there are some cross-chain operations that might just use the very loosely coupled oracles to kind of act as the way to bridge the gap. So like for an example, instead of requiring Bitcoin immediately, you might say, okay, why don't I create a synthetic pair for Bitcoin using Ethereum, and then have a token inside the Ethereum network so that it represents what Bitcoin is. So like you put up money in Ether, but it's like priced in Bitcoin. So you have wrapped Bitcoin essentially, but that might not even require a collateralized Bitcoin. Now, when you start doing that, when you start making call out from Ethereum to everywhere else. So what happens in Ethereum? You have a miner that's basically a general computing platform, and it runs a EVM bytecode, right? So when you run an EVM bytecode, which is think of it like an assembly code. So you have a Solidity, which is a high level language, and it compiles down to EVM bytecode. And the miners have to run these EVM bytecode in their computers, essentially. And when these computers run these instructions, some of them may have to just make an HTTP request out. So which means that if you're a miner and you are smart enough, you can do a lot of damage. So for an example, you can make a call out to, let's say I have a smart contract that says, make a call to wolframalpha.com, right? But instead of calling to wolframalpha.com, miner who has their own DNS rebinding might call out to their own service, but call to wolframalpha.com and give me falsified info. So it's very important that you design your system around these kind of traditional attacks, which it's just a DNS rebinding issue, right? Like, so you just have to think about in the context of the code execution, how does it reach out to the internet? So there's also like miners can cherry pick transactions, so they can look at very specific patterns and then only run those transactions and construct blocks from that. Finally, authenticity is a very different problem than validity. You guys are all software professionals, so you know. If I just told you, something is authentically, reached out from, I got it from Sonoma Valley, this wine, right? I got it from Sonoma Valley. That's authentic, but that doesn't mean that it's actually wine inside the bottle. So validity is a very different problem than authenticity. So even if you reached out to the right source, temperature that they told you might not be exactly correct. So that's something to kind of keep in mind when you're working with an Oracle. There are different solutions out there. So one of them is Oracleize. So Oracleize solves the authenticity issue. And then there's Chainlink, which solves the data validity issue. So you have, you pull multiple sources and say, okay, temperature at San Francisco, what are they? And 3 different sources tell you, and through Chainlink. Now, cross-chain settlement. So now we're talking big. Yes?
Yeah, question about Oracle. This is my first time.
Oh, no worries.
I know this term. So for every specific chain, there's only one Oracle for this chain?
Oh, no.
Or is that limited?
No. So Oracle is just a classification. Whenever you reach out to somewhere else you get information from outside of the blockchain, then that's called an Oracle. That's it. It's just a very fancy way of saying you're just reaching outside from the blockchain.
So since I'm building a blockchain a prototype, I have a client.
Yeah.
This client is just feed data to the chain.
Uh-huh.
So this client is an Oracle. Right?
So a point of a clarification might be if you have something that modifies the contract from outside because it has a write access to, that's not quite an Oracle. If the contract reaches out to some web service or whatever, then that is an Oracle. That web service is construed as an Oracle. So if you if you have something that changes the contract itself, then that's just you having access, write permission to that contract address.
Oh, I see.
Yeah. So that's a little different than Oracle. So it's like it's like talking to somebody versus writing a diary.
So this is only applied for the Ethereum network.
I'm sure there are oracles in different blockchains. I'm not very familiar with EOS or Cardano or stuff like that, but I'm sure they have primitives that allow you to do that.
Yeah.
So kind of external server, this Oracle is actually the smart contract. If they can just call out of the server to grab information, that server will be the Oracle.
That's right. The server that you reach out to from the smart contract is called Oracle, or any information source. So the cross-chain settlement is like the easiest thing you can think about when you deal with working with multiple blockchains. So a pragmatic way might be to have a collateral that you collateralize and lock everything, and then say, okay, based on some rule, now do a swap. So that's one way to do it. So there's different ways to do it. So one is the pre-commitment model, where you send out a bunch of conditional transactions into the blockchain. You just say, this transaction will execute if you meet these conditions. So you just send them out, but it's not spent yet, quote unquote. which means that the transfer of Bitcoin from one address to another that didn't happen yet. So that, which means that all of these like pre-committed transactions are ready to be run as soon as like someone's willing to spend it. Now the escrow model is basically, it's actually a lot simpler. Escrow model is a lot simpler because what you're saying is you just send money to some address and then there's some program running on it and then it spits it back out to you.
It's not clear to me on the collateral,
Uh-huh.
how the collateral is mutually accepted by the two different blockchain operating with two different set of rules to two different entities, two
Right.
different currencies,
Right.
different of everything.
Right.
How do they agree on the collateral?
So that's perfect. So now, and I'll go to that more in detail when I talk about hash time on contracts, but that is the summary of all the entire talk, right?
Hold on, I'll wait.
Yeah, oh, no. So the long story short, basically if the two different blockchains share similar primitives or similar opcode or similar hashing algorithm, then it is possible to have a atomic swap based on collateralization. But it's not always the case. For example, Ethereum and Bitcoin has vastly different models. Now,
Also, are you saying that this problem cannot be solved for universally across different blockchains, but only in a subset?
Correct.
Okay, got it.
correct, and therefore you need a sort of a engineering solution might be to have a interoperability chain in the middle or have centralized service or something like that. But there is a way to do it if the chains exhibit similar characteristics. So multi-party settlement is very complicated. I'll be happy to talk to you about it. Sometimes I get confused on that as well. The intermediate chain could be used, like we discussed. And so we're going to talk about hash time lock contract. And I don't know whether this dash should be there, but anyways. So hash time lock contract, what is it? So it's a combination of time lock and hash lock. And so hash lock is something that unlocks if you have a if you know the secret to which the hash gets generated. And time lock is it just expires like say 48 hours or 24 hours. So it's a combination of those two that creates a very clever mechanism for atomic swap. And so I kind of covered a lot of it. Now it's also refundable, which means if one party didn't meet their obligation, then you could probably get your money out. So that's a really good thing. And lastly, it's a pre-commitment model, which means you stage the transaction. So you publicly let everybody know this transaction executes if you meet some condition. And I don't expect you to read all this and understand, so I'm gonna this is even worse, right? So I'm gonna go through it really quickly. So think of it like this. Think of it like, say, Alice and Bob wants to trade, and Alice has Bitcoin and Bob has Litecoin. So they're very similar blockchains, and they use a similar hashing algorithm. And therefore, you can do one of the following. So Alice says, okay, look, I'm gonna create a transaction that you, Bob, can use to get money out, and that's transaction 1. And what that is if you have the secret password, then you can get the money out from that transaction. So that's 1. Secondly, Bob says the same thing, except on Litecoin side. Basically it says, okay, if you Alice has the secret, then you can get my money out. So you'll say like, what? You're just giving her the money because she's the only one with the secret. Well, I'll get to that. It's an interesting model. But what I didn't write, and I should have, is that when Alice takes the money out of this transaction, she has to broadcast to everybody what that secret is. So which means that, okay, here's a secret that you, Bob, can use to execute this transaction now. Mm-hmm. So which means that there's no requirement for Alice to tell Bob directly, and therefore it's automatic. So it's not automatic, but it's a it doesn't require, there is no hostage taking. Alice can't just like withhold secret in order to prevent Bob from taking money out.
But she didn't reprogram the secret, assuming she's fast enough.
That's right, and that's why you pre-commit the transactions. So therefore, the hash.
Which is soft commit, that's what pre-commit or?
So what you do is you broadcast a transaction that has all these parameters already built into it at the same time. And what that means is she can't change the secret after broadcasting these transactions because it's now written into the blockchain. So now these P2SH or the contract addresses have this parameters already built in. Bob can spend it once he has a secret. So I'll cover this really quickly. I'm sorry this is not very intuitive. So what does this all mean? So I'll start from the very beginning, and I may have to take 10 minutes to do this. So Alice creates a secret. So it might be a random number or something like that. So it's just a bunch of numbers. And after that, Alice creates two transactions. One is to allow Bob to take money out from network X. Second is to send it back to Alice. So this is an expiration. So let's say that they weren't able to agree to a term. Then 48 hours later it goes back to her. Bob does the same thing. Creates a transaction. Transaction 3, which is for Alice to take money out, say this is Litecoin, and then transaction 4, which if it expires, Bob gets his money back. Now, the important part really is once you submitted these transactions to the networks, they're already there. So Alice and Bob cannot change the terms of this atomic swap. So that's already baked into the system. And after that, what happens is now 3, 4, and then 5, now I'm having trouble. All right, so Bob signs the transaction 2, and then sends it to Alice and says, okay, now you can start the process of executing these transactions. Because Alice already sent out a TX2 saying, you can use this to start the swap. So Bob signs it, sends it back to Alice, and then Alice then says, okay, now I can use the result of TX2 to get the money out from the network Y, which is this. So using her own key, she can now spend that money. So after that, because Bob will see the secret that's in the network Y, because it's part of a transaction script. So if you're talking about Bitcoin script, it's all plain text. So the secret is already plainly written into the transaction. So Bob can read the secret and then using that, get the money out of network X, which in our case would be Bitcoin. So now they did cross-chain swap. And if you're having trouble understanding this because it's first time, same. For me, it took me a very long time to go through this. Yes?
Why are transaction 1 and 3 not time expired?
Yes, they are. So in fact, so the transaction 1 is pay coin X to Bob's public address if Bob knows the release secret. And then transaction 2 is paying coin X from transaction 1 back to Alice's public address, and it expires in 48 hours. And then the same on the other side, except Bob's expiration is 24 and not 48 hours. So yes.
I'm sorry, maybe you be done with it?
Yes.
So what you depicted in this diagram is sort of the kind of peer-to-peer decentralized model of an exchange. Is that correct?
Correct. Yeah.
Is that correct?
That's absolutely right. This is atomic swap as described by Tier Nolan, which is an online persona, and Mike Kern. Mike Kern is a very well-respected figure in the cryptocurrency world, and Tier Nolan, if you go to Bitcoin forum, kind of describe this process of atomic swap between the similar similarly ruled blockchains. So yes, this is, but yeah, absolutely. But the problem with this is that all this requires intervention, right? You need to listen to the network activity on Y and then transmit the transaction correctly on X. It's very confusing. I'd be happy to kind of go through the flow after the fact, after the session, and kind of walk you through it one by one. I'm so sorry that I can't make this any easier. But the basic idea behind it is that you pre-commit the transactions that you can back out of. So the rules are already there, and so one condition has a timeout so that you get your money back if no one executes it, and the second condition is once one party spends the transaction using the secret, then the other party knows the secret just by virtue of that secret being released into the wild. So that's the basic concept of it. The coordination part is very important too. So like say Alice wants to, spend at the 23rd hour and 59 minutes, that's actually against her own better judgment, because if she does that, then she could actually lose out on the whole deal. So she might be out of the coin. So it's just it's a very elegant way to do it, but it also requires a very focused mindset to kind of come up with something like this. And there are different ways to do atomic swaps as well. And again, if everything is internal to the same chain, then escrow model is just fine, because then you can just write a smart contract rule that does it. So now Blockstream, which is a big name in Bitcoin world, came up with a concept called sidechain. So what it is a federated chain that has a similar rule set as the main chain. So like say Liquid Network, which is a Blockstream's own sidechain, has a very similar rule set as a Bitcoin main chain, but it also has extra operations and things of that nature. Now, what's the benefit of that? Benefit to that is then the participants in the network gets to determine how quickly things get resolved. So if you're a part of this federated network, then you know what? Maybe you're an exchange. Maybe you have a lot of money at stake and you want to use a side chain to send money faster or something to that effect. So it does come in handy. Now, what that means is you still have to have a collateral. And if you don't understand the mechanism of the side chain very well, then you might not want to participate in it. So make sure that if you are, then just read up on the rules. If you're building anything, read up on the rules for the side chain that you're participating in. So depending on how compatible the side chain is to the main chain, you might be able to also do merge mining. So if you do merge mining, then you're getting money from two different chains. So that might be profitable for you as a miner, but if you are also worried about bootstrapping the security guarantee on the side chain, then making it compatible so that the miners would participate in your side chain mining, that immediately increases your hashing power, right? Which means that you're getting all this for free. Well, not free, but you get the idea. So you can bootstrap your hash power very quickly by making it, amenable for that. So there's a bunch of different examples. Liquid is one. Rootstock is another. So drive chain is a very interesting idea because it kind of makes people think about, okay, how do we take this sidechain idea and expand it, in a different spectrum? So it's a meta protocol on main chain. What does that mean? So I'm not an expert on drive chain, so I'm sure people online will, yell at me, and I hope they do, so I can learn more about it. But basically, what it means is the side chain doesn't rely strictly on what the main chain does, except when the settlement occurs. So what that means is, in drive chain terminology, you want to take, instead of like party-to-party, two-party escrow, like for example what we saw in hash time lock contracts, drive chain has a escrow that is designated for the entire side chain participant. So what that means is it opens up a possibility for settlement that is kind of crossing the boundary. So let me give you an example. So in the HTLC, you can only trade with people you already know because you have to create that bi-directional relationship. But in drive chain, you could create a participant pool or something like that, or escrow, I don't know the exact term, that allows the participants to, when you settle with some arbitrary party in the future, the participant, the drive chain could take that money out because they have the secret to be able to take that money out. So it's a very interesting idea, but it requires an additional coordination. So what that means is the drive chain every 90 something days takes a snapshot of Bitcoin and say, okay, well, now I need to look at what happened on the drive chain versus what happened on Bitcoin network, and then kind of reconcile the difference. So there is some snapshotting that's required. Now, which means that you might also need the soft fork, and miners might need to participate. But if there's a lot of value that it brings, maybe that's worthwhile looking into. I don't know. So Rainbow Network is something that Dan Robinson came up with. He's a very smart fella, and so a lot smarter than I am. But the basic idea is you might not even have to have a interoperability layer if it's mainly for payment that requires some kind of collateralization. You might just have to rely on oracles. So say if you have reliable oracles out there, say like multiple exchanges that tell you what the prices are, then what you could do is create, in his words, synthetic pair or synthetic instrument. So what that means is you create a tokenized form of Bitcoin inside Ethereum network that is collateralized by the price, or you have to collateralize it to meet the price obligation. So you can put in Ether to this, some sort of contract that is priced in Bitcoin. That way, if the price of Bitcoin goes up against Ether, then you have to put in more Ether to make sure that your obligations are met, or something to that effect. So, which means you have, you have loose coupling, and when you have loose coupling, then that allows you to kind of run things without having direct interface between the different blockchains. So synthetic pairs are interesting, but again, the fault of that is it relies heavily on oracles, which means that you might not be able to do certain things that you want, and also if you want to have a price setting behavior, relying on oracles to have a synthetic instrument pricing is not really going back to the demand and supply side of things, right? So if you're trading in, exchanges, then there's actually demand and supply that settles the spot requirement, but if you have a synthetic obligation, then it's relying on the price only and not the actual demand and supply. So, which is, I don't know. I'm not an economist, so I can't really tell you how important that is, but I think it's kind of important. So Cosmos is an interesting way to kind of try to have a hub of activity. So you have kind of hub and spokes model where you have Cosmos acting as an intermediary for multiple chains, and you have to have a common consensus mechanism within the participants in the Cosmos network, so that you minimize the problem that could arise with things like different consensus rules creating different asynchrony and different finality rules creating different problems. So you want to have a single rule set in the hub chain, there you go, and then which runs this very interesting consensus mechanism called Tendermint. You're gonna have to read the actual paper. Unfortunately, I have a hard time explaining the HTLC, so it's gonna be a lot more difficult to go through Tendermint. But what that means is the participant zones with, say, it could be Bitcoin, it could be Cardano, or whatever, or EOS, or whatever, could use their own consensus mechanism, but they do have to have a bridging mechanism that uses Tendermint. So they need something that goes from their, mechanism to Tendermint, and which means pegging zones. Now, it says Q&A, so we are Q&A.
What would be a perfect scenario where a smart contract can do better than traditional ways?
It really depends. I mean, so smart contracts are just, a program running on internet, right? So which means that traditional ways of transacting could be anything like, if you're talking about payment network, it's a proprietary protocol in some, Visa or something like that. But if you have multiple participants that might not want to pay to, play, maybe a public blockchain with its own smart contract is a sufficiently good solution. Then you can have a very common network that is programmable and has similar features.
Yeah, just to add to this, like in financial services world, the area of trade finance, where at least six parties are involved, and it's the buyer, the seller bank, the buyer bank, the tax authority, the shipping authority, all of those parties, like especially international trade finance. Letter of credits come from one bank to another bank. It's a very complex process, mostly manual. Blockchain or several blockchains, because you have several banks maybe running different blockchain. That's a classic solution for this problem, because today it's just a mess. It's all manual, and it's a bunch of documents, faxes, whatever, going back and forth. So this is a low-hanging fruit.
Right.
Are people using
People
it?
doing, yeah.
This platform
Yeah,
now?
again, how much of this is theory and how much is actually in operation by the banks? I mean, the banks are notoriously kind of conservative bodies because they have to comply, right? There's regulations. So, but a lot of banks have been experimenting with blockchain, and then the bridging of different blockchains, because of course, bank in country A and the bank in country B will not run the same blockchain.
Right. So I mean, the going back to your answer now, smart contract is native to one blockchain. So which means that if it solves in one blockchain, then that might be sufficient. So in the context of using it across different blockchains, if you have a settlement that requires same rules in two different blockchains, then you will probably have to write two different smart contracts in two different blockchains that have same rules. So which means that you have to understand multiple programming languages in different blockchains. For an example, RSK rootstock actually tries to make it easy by using Solidity, which is the same language that Ethereum uses. But more fundamentally, going into your question, smart contracts is a great way if you need a neutral ground to use blockchain as a place for settling, a place for recording data. And one example might be real estate or titles for cars or something like that. So imagine Carfax, just dumping all that data into Ethereum or something. I don't know. That's not my business. I really don't know. Hope that helps. Any other questions? Yes.
So on the same example of 6 parties involved in
Yep.
a transaction
Uh-huh.
and banks being conservative because of regulations,
Mhm.
how much of regulations have caught up to blockchain and
Oh
cryptocurrencies
boy.
so far?
So
Good question.
so you're 2 for 2 on excellent questions. Now I think that the regulators in general. So there is a blockchain caucus in Washington D.C. Regulators in general are more concerned with financial aspect of the blockchain, much so than the sort of like the code as law aspect of blockchain, which is unfortunate because there's a lot of room for growth in code as law, or computational law aspect of it. So there isn't a lot of focus in that, unfortunately. But there is some regulators who are very savvy about this, and the people across different states have started to say, okay, fine, if you incorporate, you can actually publish your corporate documents in blockchain, and we'll accept it as such. And now it's a legal document that is everywhere. So, which makes sense because if you have your own private key and if you sign the document using your private key and you push it out to public blockchain, then that's just as well as having a some notary verify who you are. But of course, there's downside to it, which is, it only verifies that you had your key. It doesn't mean that you were that person. So there's a lot of linkage to real world that still hasn't quite caught up, and I can foresee that being a big business in the future. So the identity part is big, reputation part is another part, and the computational law part is the third part. So like in the cryptocurrency world and blockchain world, code is law has a very different context than say code is law in rest of the world. So in the blockchain world, you want to be overly restrictive so that there is no other ways to game the system. So when someone says code is law, it's literally law. There's nothing else you can do. But in real law, that's not the case. The law is very interpretive, and it's based on sort of thousands of years of jurisprudence, which is very difficult. Yeah.
I have to ask you this question.
Sure.
Facebook, Libra. If you your company, you guys experimented with chaining Libra to, let's say, Ethereum, and I know it's very different paradigm there, different language, different.
Sure.
But some of the concepts are similar. So
Yeah.
have you experimented with Libra?
So Libra is very interesting because technically it's very well done. So the interfacing with it and tooling around it is very awkward, but if you go through the technical white paper, it's generally pretty solid. The problem, of course, is, and even before we're talking about problems, Libra has a very different model of finality, meaning that it doesn't collect, to the best of my knowledge, doesn't collect transactions in a block and then tries to solve for it. It's basically every transaction that goes out the door gets verified by verifiers, the industry partners. So which means there's a transaction level finality, which means that there's no rollback. Or you can have a rollback because of finality. So it is pretty solid tech, although politics being what they are, I doubt that they are. Who knows? I don't know. I don't know anything.
Have you
about that.
cross-chain Libra to, let's say, tried that?
Oh,
to
geez.
anything?
I unfortunately have not had had too much time to play with it. I've only looked at it from one angle, but not interacting with the cross-chain aspect of it. Yes.
A follow-up on this Libra topic.
Mm-hmm.
So I actually heard the Congress hearing about Libra
Uh-huh.
2 days ago, and the sense I'm getting is that the regulators don't want anything to undermine dollar, fiat currency.
Yeah, I mean,
So whether it be Libra or any cryptocurrency,
Sure.
they just don't want anything to.
well, yeah, I mean, as a founder of a startup, I would hope that congressmen and congresswomen look into this blockchain industry with a sober eye and hear what the entrepreneurs have to say, and not get too hung up on sort of whether it's a challenge to the sovereignty of the country or not. In Libra's case, it's very difficult because Facebook is so big. But if I'm just creating smart contract that has a programmable flower that exists on Ethereum, I sure hope that I don't get penalized by U.S. Congress. It has to do with the scope of things. I think if the impact is small, then maybe regulators should be more lenient.
Right.
But I have no position on this.
Right. If you use blockchain for smart contract, then they're okay with it. But my point is that any currency that can challenge dollar will eventually be facing the regulatory resistance.
Sure.
If they have the
Sure. I mean, but going back to. Oh, no, it's absolutely necessary to try, and because of the following reason. So if you go back to before there was a central bank, you had regional private banks issuing notes. And the reason why there was a centralization is, there was a lot of people were afraid that there would be, it's like using common metric system, right, across the board, meaning that if you have dollars issued by one bank, it might not be redeemable in the next day. But I don't know if that's true. I'm not an economist. Maybe the private banking is better than a central banking. Who knows? I really am not the suited for this. I only know how to program things. So I'm sorry, I'm not giving you a very satisfactory answer.
I was just going to add to that, right? I mean, the reason big governments are interested in this, is because they're looking at taxation, right? That's a big source of revenue.
Right.
Right, and they can control that through fiat
Yeah.
currencies very
Oh,
easily.
I do have something to say for that, and it has to do with there's a county in New York called Berkshire, not to be confused, Berkshire Hathaway, that issued their own local currency called Berkshires, and it's 1-to-1 redeemable to US dollar, and in fact there's nothing in US rules or laws that prevent you from having a local currency, as long as it's taxable. So make it taxable, make it illegal, and you're golden. So thank you so much for opportunity to talk to you, and just please let me know.
Thanks, Jay. It was great. If you want to talk to Jay, we've got like half an hour of networking, so if you want to ask him more questions. Also, I wanted to tell you that we have an event on the 6th of November in Shepherd Mullen, Palo Alto, called State of Tokens. And as you know, and I noticed that people are discussing this, there has been quite a few hits from the SEC to STOs. So we're actually we've got quite a few big names for that event. If you want to come along to that, you'll find it on our website, or you'll receive a newsletter with the links to this video, and there'll be a link to that. Thank you very much for coming. Did you want to do the raffle?
Yes.
So now the big raffle with the tablet is going to be happening.
You want to hold this one?
Of course, yeah.
Okay, so the winning ticket is 9782.
It's a lucky person.
Yeah.
Whoa!
Alright.
Good work.
Thank you. Thank you.
Thanks again, Erin.